Okay, let's talk about API. Basically, they're like secret shortcuts between different apps and services. Imagine you're ordering a pizza. You don't need to know *how* the kitchen makes it, right? You just tell the waiter what you want. An API does that for software. It lets one program request information or actions from another without getting bogged down in complicated internal processes. Let's talk about what an API developer does. Essentially, they're the architects and builders behind how different software applications talk to each other. A big part of their job is designing these API, figuring out exactly how data will flow between systems. They actually write the code, build the API itself using languages and frameworks, and then make sure it's working correctly through thorough testing. Security is super important too. They need to protect the API from bad actors. Finally, they keep an eye on how the API being used and fix any problems or add new features as needed. Okay, let's dive into the different types of API you'll encounter as an API developer. We have a few major players: REST, SOAP, GraphQL, gRPC, and WebSockets. REST is probably the most common. It's stateless, meaning each request contains all the information needed to be understood. It uses standard HTTP methods like GET, POST, PUT, and DELETE. SOAP is an older technology that relies on XML messaging and a defined protocol, offering strong security and transaction support, but can be quite complex. GraphQL lets clients specifically ask for the data they need, which helps avoid sending unnecessary information. gRPC is known for its speed and efficiency, using protocol buffers to define messages. Finally, WebSockets provide persistent connections for real-time communication. Think live chat or updating dashboards. Okay, let's talk about how we actually do things with API using HTTP methods. Think of them as the instructions you give to a server. We have 5 main ones: GET, which is used to just retrieve information; POST, perfect for creating new data like adding a new user to your database; PUT, which replaces an entire existing resource entirely; patch, for making targeted changes, updating only specific parts of something; and finally, delete, which removes resources completely. Knowing when to use each method is fundamental to building good API, so let's keep this in mind as we continue learning. Okay, let's talk about how API communicates success and failure. HTTP status codes are like a little report card for every request your API receives. A 200 OK means everything's great. The server understood what you asked for and did it perfectly. Numbers in the 200s usually indicate successful creation or retrieval. Now, if you see something like 400 bad requests, that tells you there's a problem with your * request. Maybe you missed a required field or sent some data in the wrong format. Similarly, 401 unauthorized means you need to prove who you are, and 403 forbidden means I know what you're trying to do, but I just can't let you. Finally, 500 internal server error is a general that something went wrong on our end. It's really important to handle these errors gracefully by providing informative error messages, logging them for debugging, and using consistent error formats so developers can quickly figure out what needs fixing. Got it? Okay, let's talk about designing good REST API. The foundation is built on a few key principles. First, we want everything to be uniform, using standard HTTP methods like GET and POST consistently across your API. Then, think about how you structure your URL. They should clearly represent the resources you're working with. And finally, remember that statelessness means each request from your client needs all the information it requires, no server-side memory of previous requests. Now, let's move on to some best practices, like using HTTP status codes correctly to give clients meaningful feedback and implementing versioning so you can evolve your API over time without disrupting existing users. Okay, let's talk about how we name our API resources. It's super important to do this consistently. Think of it like building a well-organized house. We always use plural nouns for collections, like users or products. And everything should be lowercase with hyphens separating the words, so you get things like user profiles. It might seem simple, but clear naming makes your API much easier for other developers to understand and work with. I've included a little table here as an example of how it looks in practice. Okay, let's talk about how API actually communicate. Think of it like sending a package. You need to know what's inside the data and how to deliver it correctly. The first thing to understand is the structure of requests and responses. We have three main parts: headers. These tell the server how to handle your request, like saying here's JSON. The body contains the actual information you are sending. Think of it as the contents of that package. Finally, there are query parameters, which are extra bits of info you might add to the URL itself, like instructions for where to deliver the package, so it can be sorted or filtered correctly. Let's talk about keeping your API safe. Authentication is all about verifying that whoever's asking for data is actually who they say they are, like showing your ID at a club. Authorization then takes it a step further, deciding what you're allowed to do once you've proven your identity. There are several ways to handle this, from simple API keys to more complex systems like OAuth 2.0 and JWT. RBAC and ABAC are popular authorization techniques. Think of RBAC as assigning different levels of access based on roles, and ABAC, which is a dynamic way of controlling access based on lots of factors. Let's talk about securing API access. We're diving into OAuth 2.0 and OpenID Connect, two powerful tools that help apps like yours connect to user accounts safely. Think of OAuth 2.0 as a way for an app to get permission, like a key to access things on a user's account, like their photos or contacts. OpenID Connect takes this a step further by actually verifying who the user is, confirming their identity with an ID token. Essentially, it's using OAuth 2.0 as a base for secure authentication. It's all about keeping your users' data protected and giving them control over what information is shared. Okay, let's talk about how API prove who they're talking to. First up are API keys. These are like simple passcodes for your application when it needs to access an API. They're quick and easy to set up, but not the most secure option. Next we have JWT, or JSON Web Tokens. Think of them as digital badges that contain all sorts of info about a user. They're stateless, which means there isn't any session storage needed in the server. Finally, let's cover session-based authentication. This is the classic approach where the server creates a unique session for each user and stores information related to them. It's more complex but can be very effective. Let's talk about CORS, which stands for Cross-Origin Resource Sharing. Essentially, it's a security feature built into web browsers that stops one website from just willy-nilly accessing data on another website. Imagine you have a login page and an API that stores user information without CORS. A malicious script could potentially steal those credentials. It works by the browser checking the origin of a request. The server then responds with headers to tell the browser if it's okay to proceed. You'll see some key headers like access control allow origin, which defines which sites can access the resource, and access control allow methods that list what types of requests are allowed. Okay, let's talk about rate limiting and throttling, essential techniques for any API developer. Basically, it's all about managing the number of requests your API receives from a single client within a specific time frame. Why do we need it? Well, it protects against things like denial of service attacks and ensures your servers don't get overwhelmed. There are several different approaches, things like the token bucket algorithm or leaky bucket, which help smooth out traffic spikes. And then there's fixed window counters, a simpler but effective method for controlling requests within set intervals. Understanding these options is key to building robust and scalable API. Okay, let's talk about how to handle those massive data sets you sometimes get when working with API. When an API returns a huge amount of information, like, say, hundreds or thousands of posts, you can't just load everything at once. That's where pagination comes in. We're going to cover three really common and effective techniques. First up is offset and limit. This is probably the easiest to understand. You tell the API start here the offset and give me this many items the limit. Then there's cursor-based pagination, which uses a kind of breadcrumb trail, a cursor that tells the API where the previous page ended. Finally, we have token-based pagination, often seen in database scenarios, using unique tokens to navigate through the data. The best choice really depends on how the specific API is designed and how your data works. Okay, let's talk about versioning. It's absolutely vital when building API. Think of it as a roadmap for how your API evolves over time. A really popular approach is semantic versioning, which uses a simple format like phone.to3. Major updates mean big changes that existing code might need to adapt to. Minor updates add cool new features without breaking anything. And patches are just small fixes to bugs. They are backward compatible. You can also version your URL like /API/phone/users or even use headers or query parameters, but the key is to be consistent and let your clients know how to find the version they need. Okay, let's talk about API gateways. Think of them as the front door to your API. They handle all the traffic and make sure everything runs smoothly. We've got a few big players: Kong, which is super flexible and great for custom setups. O's API Gateway, that's really easy to use if you're already in the Amazon world, and Apigee, which is designed for larger businesses with more complex needs. Basically, they all provide essential features like routing your requests to the right place, making sure people are authenticated before accessing anything, and even managing how many requests a user can make at once. That's rate limiting. Okay, let's talk about API proxies versus API gateways. They both help manage how different parts of your application talk to each other, but they do it in fundamentally different ways. An API proxy is like a simple traffic cop. It just directs requests to the right backend service based on the URL. It's really focused on routing and basic load balancing for a specific API or a small group of them. On the other hand, an API gateway is much more sophisticated. Think of it as the central control tower for your entire API ecosystem. It handles everything from making sure users are authenticated to managing traffic flow and even transforming data before it reaches the backend. Basically, if you've got a lot of API or need advanced features like security and monitoring, an API gateway is generally the way to go. Okay, let's start with the basics of GraphQL. It's a really powerful way to interact with API, and it's different from what you might be used to with REST. Basically, instead of making multiple requests to different endpoints to get all the data you need, GraphQL lets you ask for exactly that, no more, no less. It has three main parts: queries, which are like asking for specific information; mutations, which are used when you want to change something on the server; and subscriptions, which allow your application to automatically update itself whenever data changes. Okay, let's talk about choosing the right API design, specifically GraphQL versus REST. REST is a really common approach. It's all about resources and using standard HTTP methods like GET to retrieve data. It's simple and scales well, but sometimes you end up with too much information being sent back. That's called overfetching. And if you need related data, you might have to make multiple requests. Now, GraphQL is a different beast entirely. It lets the client ask for precisely what they need, avoiding all that wasted data. Think of it as more flexible and efficient. It has a bit of a learning curve, but the benefits in terms of performance and developer experience are often worth it. Okay, let's talk about gRPC and specifically how protocol buffers and bidirectional streaming work together. Protobuf is like a super efficient way to package data. It's much smaller and faster than other formats because it's binary. It defines the structure of your messages in a schema that's easy to update as your API evolves. Now, with bidirectional streaming, gRPC isn't just about sending one request and getting one response. It allows for a true conversation between client and server where they can send multiple messages back and forth at the same time, perfect for things like live chats or constantly updating data streams. Okay, let's talk about WebSockets. These are a really powerful tool for building modern API. Think of them as a constant two-way chat channel between your client, like a web app or mobile app, and your server. Unlike regular HTTP requests that need to be sent back and forth all the time, which can cause delays, WebSockets keep that connection open, letting you send data in real time. This is fantastic for things like live dashboards where information needs to update instantly, or chat applications where users expect immediate responses. They reduce latency significantly, and crucially, they allow both sides, your client asterisk and asterisk your server, to talk at the same time, not just request response. Okay, let's talk about making sure your API stays safe. We're focusing today on two really important things: validating requests and sanitizing the data they contain. Think of validation as a gatekeeper. It checks that every incoming request is actually what you expect, like making sure all required fields are filled out and the data types match up. Then, we have data sanitization, which is like cleaning up the data itself. It's about removing or encoding anything that could be harmful, preventing things like cross-site scripting attacks, or protecting your database from malicious SQL commands. Remember, these two steps work together to create a much more secure API. Okay, let's talk about keeping our API safe and sound. Input validation is a really important step when building any API. Think of it like having a gatekeeper that checks everyone coming through, making sure they are allowed in and have the right credentials. We'll look at some popular libraries to help us do this effectively. Joy, Marshmallow, and Pydantic are all fantastic tools for defining exactly what kind of data we expect our API to receive, like confirming that a user's email address has the correct format or that a product ID is actually a number. They make it much easier to catch errors early on, preventing problems down the line and ensuring your API runs smoothly. Okay, let's talk about how API handle errors. RFC 7807 is a really important document for API developers. It's essentially a standard way to tell clients when something goes wrong. The core of it is called the problem details object. This object contains key information like the HTTP status code, that familiar 400 or 500, for example, a more specific error code that's machine readable, and a clear message explaining what happened to the user. Using this standard makes API much easier to work with, improves debugging, and allows your clients to react intelligently to errors. Okay, let's talk about idempotency, a really important concept for API developers. Think of it like this: you want your API calls to be predictable and reliable, even if things go wrong. Idempotency means that repeating the same request multiple times will always produce the same outcome as making it just once. It's key for handling network problems and ensuring users aren't accidentally creating duplicate records or triggering unwanted actions. Get requests are inherently idempotent. You get the same data every time. Vert and patch can be, but they need careful design to avoid unintended changes if called multiple times. And delete? Well, those are usually not idempotent by default, so you'll have to implement specific checks to make them safe. Okay, let's talk about statelessness and REST API. It's a really important concept for building scalable systems. Basically, when an API is stateless, each time your client, like your web app or mobile app, asks the server for something, it sends all the information it needs to fulfill that request. The server doesn't remember anything about previous requests from you. Every interaction is fresh and independent. This makes scaling much easier because servers don't have to worry about managing user sessions, and it also improves reliability. Let's talk about OpenAPI, also known as Swagger. Think of it like a detailed blueprint for your API. It describes exactly how all the parts work together, what data is involved, what requests you can make, and what responses you'll get back. Using an OpenAPI definition helps us automatically create fantastic documentation that's easy to use, and even generate code to help build our API more quickly. It also ensures everyone on the team has a clear understanding of how the API should work. Okay, so as an API developer, you know how important it is to document everything. Swagger UI and Redoc are two amazing tools that can make your life a whole lot easier. Swagger UI is like a live interactive playground for your API. You can actually test out the endpoints and see what data comes back right in your browser. It's great for quick exploration. Redoc, on the other hand, takes your OpenAPI definition and turns it into beautiful, static HTML documentation that's perfect for publishing. Think of it as a really polished way to share your API with others. Okay, let's talk about testing your API effectively. Sometimes you don't have a live service to test against. That's where mocking comes in handy. We've got some great tools that can help us emulate API responses without needing actual backend services running. Postman is super popular. It's really good for collaboration and handling complex requests. Macoun is fantastic if you just need something quick and easy to set up for prototyping. And then there's WireMock, which is a powerhouse when you need more control and advanced features. Think of them as your API testing buddies. Alright, let's talk about keeping an eye on your API after they're live. That's monitoring and analytics. Think of it like a dashboard for your application. You need to see how things are really doing. We'll look at some key metrics: response time, error rates, and request volume. These numbers tell you a lot about what's going on. Then we'll touch on a few tools you can use to gather this data, like APM platforms, logging systems, and even your API gateways themselves. Getting these insights is essential for maintaining a healthy and performant API. Okay, let's talk about how to really understand what's going on with your API, specifically logging and observability. Logging is basically like keeping a detailed diary of everything that happens when someone uses your API, the URL they request, who made the request, whether it was successful or not, and any errors that popped up. We want structured logs using JSON so we can easily search them later. Then comes observability. It builds on logging by giving us a bigger picture. It combines metrics like how long things take, logs, and traces to help us diagnose problems quickly and understand the overall health of our services. Think of it as piecing together all the clues to figure out what's really happening. Okay, let's talk about keeping your API safe. The first thing to focus on is verifying who's asking for information. That's authentication. Then we need to make sure they only get the stuff they should be getting authorization. Next up, always check and clean any data coming into your API. Think of it like a gatekeeper protecting you from sneaky attacks. Rate limiting helps prevent someone from hammering your system with too many requests. And finally, always use HTTPS to keep everything private while it's traveling between the client and your server. Okay, let's talk about keeping your API safe. The OWASP API Security Top 10 is a really important checklist for any API developer. It covers 10 of the most common and dangerous vulnerabilities you'll encounter. We're talking about things like injection attacks, where bad data slips and broken authentication that lets unauthorized people in, and exposing sensitive information. Logging everything carefully can help you spot problems quickly. Don't forget to update your dependencies regularly, and always validate any input you receive. It's a lot of work, but it's crucial for building secure API. Hey everyone, let's talk about protecting our API, specifically how we can handle SQL injection and cross-site scripting attacks. SQL injection happens when someone tries to sneak malicious code into a database query, potentially exposing sensitive information or messing with your data. The best way to prevent this is by using parameterized queries. These treat the data as data rather than executable code. Now, XSS. This is where an attacker injects JavaScript into a web page and it then runs in other users' browsers. Think of it like planting a little malicious script. Prevention here involves carefully encoding any user input before showing it to others, and setting up content security policy which helps control what scripts can actually run on your site. Okay, so when it comes to API security, tokens are really important. They are what allow your applications to access data securely. But you need to be super careful about how you store and transport these tokens. The best practice is to send them as part of the HTTP request, typically in a header like authorization bearer. Think of it like giving a key. You don't want to write it down. Also, make sure your tokens aren't valid forever. Shorter expiration times mean less risk if one gets stolen. And for longer running apps, refresh tokens are incredibly useful because they let your app get new access tokens without needing the user to log in again. Finally, and this is a big one, always use HTTPS. Never send tokens over plain HTTP. It's like shipping something fragile. You need a secure delivery. Okay, let's talk about protecting our API, specifically through rate limiting. Rate limits are basically like guardrails. They restrict how many requests a client can make to an API within a certain period. It's super important because without it, someone could flood your system and cause problems or even revenue loss. There are several different ways we can implement these limits. The token bucket method, which gradually adds tokens over time, the leaky bucket, similar but more forgiving, and fixed window limits applied on a regular interval. Understanding these methods will help you choose the best approach for your API. Okay, let's talk about caching. It's a really important part of making API super efficient. Think of it like this: instead of always sending the same data from your server every time someone requests it, we can store copies of that data in different places. First up, there are HTTP cache headers. These tell browsers and other intermediaries whether or not to keep things around for a while. Then, reverse proxy caches sit in front of your servers, handling a lot of the requests directly. Finally, CDN take things even further by distributing content across the globe, ensuring that users get it as quickly as possible. Mastering these techniques can make a huge difference in how fast and reliably your API works. Okay, let's talk about HATOs. It's a really clever approach to API design. Think of it as giving your clients hints on where to go next instead of just telling them exactly what to do with a specific URL. It's all about dynamic discovery. The core idea is that the server responds not just with data, but also with links pointing to related resources and actions, essentially creating a roadmap for the client. These links have titles that explain what they do and often include metadata to give you more context. It's a shift from rigid URL to a more flexible and adaptive interaction model. Okay, let's talk about contract testing. It's a really important technique for building robust API. Basically, it's about making sure that the different parts of your system, like the API itself and any apps or services using it, are all on the same page when it comes to data formats and how they interact. Pact and Dread are two powerful tools that help you achieve this. Pact lets consumers, the ones using the API, define what they expect, while providers make sure they deliver. Dread is a handy command line tool that makes running those verification tests super easy. It's like an automated double check to ensure everything works as agreed upon. Okay, let's talk about how API connect to our applications. There are a few key patterns we need to know. First up is synchronous calls. These are straightforward. You ask the API for something, and you wait for the answer before doing anything else. Next, we have asynchronous requests, where your application keeps working while the API does its thing in the background. Finally, there's event-driven architecture, which means your app reacts to changes or new information from the API like a notification when data updates. It's all about building flexible and responsive systems. Okay, let's talk about webhooks and callback API. They're both crucial for building responsive API integrations. Basically, imagine you have one app that needs to know when something important happens in another app. Instead of constantly checking if it's happened polling, which can be inefficient, we can use these techniques. Webhooks are like a notification system. The other app sends data to your app whenever an event occurs. Think of it as pushing information directly to you. Callback API are more like a phone call. Your app initiates a request and then the other app calls back to your app with the results. They are both powerful tools for keeping your system synchronized in real time. Okay, let's dive into some common pitfalls you want to steer clear of when designing an API. First up, we have overfetching and underfetching, sending too much or not enough data in a single response. This can really hurt performance. Next, avoid deeply nested endpoints. They make your API confusing. Versioning is crucial, don't skip it. And always validate user input to protect against security risks. A well-designed API starts with these fundamentals. Okay, let's talk about how microservices actually communicate with each other. When you're building a system using this approach, it's important to think carefully about how the different services interact. We have a few main strategies. First up is synchronous communication, basically just making simple requests and getting responses back immediately, like a direct phone call. This works well for things that need an instant answer. However, if one of those services goes down, it can bring everything else down too. Then there's asynchronous communication using message queues like RabbitMQ or Kafka. This is more robust because the services don't have to wait for a direct response. They just send a message and let another service handle it later. This approach offers much better resilience. Finally, an API gateway can act as a central hub, routing all requests to the right microservice. It simplifies how your clients interact with the system and can handle important things like security. Let's talk about how API find each other. Think of it like a giant phone book for your services. We need a way to know where each service is running so they can communicate. That's where registers come in essentially. They're central databases that hold information about all the available services and their locations. Popular options include Consul, which is a really robust system from HashiCorp, Eureka, Netflix's solution easy to get started with for smaller projects, and then there are service meshes like Istio or Linkerd which provide even more advanced features around managing how services talk to each other, including traffic management and security. It's all about making your API landscape organized and efficient. Okay, let's talk about getting your API live. We have two really effective deployment strategies, Blue-Green and Canary. Blue-Green is like having a backup ready to go. You're running two almost identical environments, one currently serving users the Blue and another with the new version Green. When everything checks out after testing, you smoothly switch all traffic over to the Green environment. It's fantastic for quick rollbacks if something goes wrong, but it does mean you need twice the infrastructure. Then we have Canary deployments. These are a bit more cautious. You release the new API version to just a small percentage of your users initially. This lets you catch any problems early on without affecting everyone. As things go smoothly, you gradually increase the percentage until you've fully rolled out the update. Canary deployments are great for minimizing risk and spotting issues before they become widespread. So, which strategy is best? It really depends on your specific needs and how comfortable you are with managing the deployment process. Let's talk about getting your API out into the world quickly and reliably. A CI/CD pipeline is a game changer for API development. It's all about automating key stages of the lifecycle. First, you have code changes which trigger the build process. Then, we automatically build and test the API, checking everything works as expected. Next, we package our API into containers like Docker, ensuring consistency across different environments. Finally, deploying to staging, then production and ongoing monitoring help ensure a smooth experience for your users. Okay, so when it comes to building API, you've got a bunch of fantastic frameworks to choose from. Let's quickly look at some popular ones. Express is incredibly flexible and has a huge community behind it, great for everything from simple REST API to real-time applications. Fast API is newer and really blazing fast, especially with its automatic data validation and support for async operations, making it ideal for modern API and microservices. Then you have Spring Boot, which is a powerhouse for enterprise-level development thanks to its comprehensive features and ecosystem. And finally, Flask is a lightweight, easy-to-learn option perfect for smaller projects or just getting started. Okay, let's talk about designing your API so they work really well with everyone no matter what language they're using. The key here is being language agnostic, meaning your API shouldn't depend on a specific language to function correctly. We want it to be flexible and easy for developers from all backgrounds to use. First, let's focus on data formats. JSON is the clear winner over XML these days because it's much simpler and supported everywhere. Next, always use standard HTTP methods like get, post, put, and delete. Stick with what's expected. Then, design your URL to clearly describe resources like /users/ID instead of relying on action-oriented ones. Finally, keep the structure of requests and responses consistent across all endpoints. Okay, let's talk about the backend for front-end pattern, or BFF as it's often called. Think of it like this. You have lots of different front ends, a website, a mobile app, maybe even some IoT devices, and they all need to pull data from various backends. Traditionally, each front end would hit all those backends individually, which can be really complicated and slow down performance. The BFF solves that by acting as a single point of contact for each front end. It takes the raw data from multiple backend services and transforms it into something perfectly suited to that specific client's needs. Think optimized presentation layers. It simplifies things for the front ends, boosts speed, and offers a better security posture. Let's talk about load testing your API. It's super important to make sure your backend can handle a rush of users, especially when something popular goes viral. We have a few great tools to help us. K6 is really easy to get started with using JavaScript. JMeter is a heavyweight champion for complex tests, and Artillery stands out because it's designed to scale well in the cloud. When you're running these tests, you want to keep an eye on things like response time, which is how long it takes your API to respond, throughput, measuring how many requests you can handle per second, error rate, we don't want any unexpected failures, and latency, that's simply the delay in data transfer. Understanding these metrics helps you build a robust and reliable API. Okay, let's talk about how we turn data into something an API can send and receive efficiently. That's called serialization. Think of it like packaging your information for transport. We have a few popular options here. JSON is super common because it's easy to read and works almost everywhere. XML used to be the standard, but it can be a bit bulky. Protocol buffers are really fast and efficient, especially when you need speed, and Avro is great if your data structure changes often. It's important to pick the right format based on what you're building. There isn't always one best choice. Alright everyone, let's talk about content negotiation in API. It's all about flexibility. When you create an API endpoint, it's great to define the expected format, but what if your clients want something slightly different? Content negotiation is how the client and server work together to agree on the best way to exchange data. It's like ordering at a restaurant. You tell them exactly what you want, and they confirm they can provide it. The client sends a request with accept headers indicating its preferences, and the server checks those preferences before sending back a response. If there's a mismatch, the server might even suggest alternatives to ensure the client gets something useful. Okay, let's talk about custom middleware. Think of it as adding specific rules or logic to every incoming request before your main application code even sees it. It's like a little helper that sits in the middle. You define this middleware as a function that takes the request object, the response object, and something called next. Inside the middleware, you can do things like check for authentication, validate data, or even modify headers. If you don't handle everything yourself, meaning you don't want to process the request fully, you need to call next to let the next piece of middleware or your main route handler continue processing. Okay, let's talk about keeping your API running smoothly. Health checks are a really important part of being an API developer. They are essentially mini tests that tell you if your API is actually working as it should. Why do we need them? Well, they help us find problems before our users notice them, so we can fix things proactively and make sure we're meeting our service level agreements. A simple health check endpoint like /API/health might just return a 200 OK if everything is good, but you can customize it to give you much more detailed information about how your API is performing. And don't forget about monitoring. Tracking key metrics and setting up alerts are essential for staying on top of things. Okay, let's talk about protecting your API with rate limiting. It's a really important step in ensuring they stay stable and don't get overwhelmed by abusive users. Basically, we want to limit how many requests someone can make within a certain time period. We'll cover some key concepts like windowing, which means setting limits of a specific windows of time, the token bucket algorithm, which is a common way to track requests, and sliding window logging for accurate rate calculations. I've included a simple code example to illustrate how you might implement this in middleware. This is just a starting point, of course. Alright, let's talk about designing an API for multiple customers, or tenants as we often call them. It's a really common scenario. The most popular way to handle this is with a shared database. All your clients use the same database, but we make sure each one can only access their data using something like a tenant ID. This keeps things simple on the management side. Another option is separate databases for each tenant, which gives you really strong protection against issues affecting one client impacting others, but it's more work to set up and maintain. Finally, there's schema per tenant, where tenants can have completely customized data structures. This offers ultimate flexibility, but adds a lot of complexity. When deciding what's best, think about things like how much security you need, how many users you expect, and how quickly your business might grow. Okay, let's talk about securing your API with authentication middleware. Basically, this code sits in the middle of your routes, checking if a user is actually allowed to access what they're trying to do. We first figure out which routes need protection, and then choose our authentication method. Things like API keys or JWT are common. Then we create a function that handles all the verification logic, and finally, we register it with your application's routing setup. It's important to remember security best practices and handle errors gracefully. Let's talk about how cloud services can really help you manage your API when they start getting big. As an API developer, dealing with increasing traffic and the need to keep things secure can be a real headache. Thankfully, there are platforms like AWS API Gateway, Azure API Management, and Apigee that handle all of that for you. These tools automatically route requests, add security layers, limit usage to prevent abuse, manage different versions of your API, and even give you insights into how they're performing. It's a huge time saver and lets you focus on building great API. Okay, let's talk about securing our API. We've reached the authentication and authorization stage. First, we need to verify who is trying to access our services. That's authentication. There are several ways to do this, from simple API keys to more robust methods like OAuth 2.0 and JWT. Once we know who they are, we move on to authorization, which asks the question, what can this person actually do? We use techniques like role-based access control and attribute-based access control to define those permissions. The API gateway is crucial here. It's the gatekeeper that enforces both authentication and authorization policies before any requests reach our backend services. Any questions so far? Let's talk about getting your API out into the world. When it comes to serverless environments like AWS Lambda and Azure Functions, we're all about scaling automatically and keeping costs low. Both platforms allow you to run code without managing servers. Think of them as on-demand computing. You'll often use containerization, packaging your API code into a self-contained bundle called a Docker image, which makes deployment much smoother. Deployment strategies like blue/green or canary deployments help ensure smooth releases and minimize downtime. AWS Lambda provides a way to run code in response to events, while Azure Functions does the same. It's all about building scalable API without worrying about server management. Okay, let's talk about making sure your API can handle a lot of traffic without slowing down. As your users grow, you need to think about scalability, how well your API can handle increased requests. Performance is key here too. People expect fast responses. We'll cover some important techniques like caching, which stores frequently accessed data so it doesn't have to be refetched every time. Then we'll look at optimizing your database and using load balancing to spread the workload across multiple servers, plus asynchronously processing tasks that take a long time. And finally, monitoring everything with tools to see where you can improve. Okay, let's talk about keeping your API safe. There are some fantastic tools out there designed to help you find and fix security vulnerabilities. First up is Burp Suite. It's like a detective for the web, letting you see and change all the HTTP traffic flowing between your app and its users. Postman Security is another great option. It's a really handy tool for automatically testing your API for common problems. And finally, OSPAP is a free and open source scanner that can do some serious digging to uncover potential weaknesses in your code. Okay, let's talk about keeping track of errors in your API. As a developer, you'll inevitably run into problems, things breaking, requests failing, or unexpected data coming through. Without good logging and tracing, figuring out why these things happen can be incredibly time-consuming. The ELK stack Elasticsearch, Logstash, and Kibana is a popular solution for centralizing your logs. Elasticsearch is the engine that stores all of this information. Logstash then grabs those logs from different parts of your API and prepares them for analysis. And finally, Kibana allows you to visualize that data in a really helpful way. Grafana Loki is another option specifically designed for logging that's known for its speed and scalability. It's great when you have lots of logs coming in. The main goal here is to be able to quickly find the root cause of any issues, allowing you to fix them faster and improve your API reliability. Okay, let's talk about tracking requests as they move around your microservices architecture. As API get more complex, it's super important to know exactly what's happening behind the scenes. That's where distributed tracing comes in. Basically, it's like giving every request a digital passport that follows it through all the services involved. Without it, debugging can be a nightmare. We'll look at some popular tools like OpenTelemetry, which is really useful because it doesn't lock you into one vendor along with Zipkin and Jaeger, each offering different ways to visualize those traces. Okay, so let's talk about managing those dependencies in your API projects. It's really important step that often gets overlooked. Basically, you need to keep track of every single external library or service your code depends on. Think of it like building with Legos. If you don't label and organize the pieces, things will quickly get messy. We use tools like npm or Maven to make this easier, automatically updating dependencies and ensuring everything plays nicely together. Also, modular design can help keep changes contained. And finally, regularly checking for outdated or unused libraries is key to keeping your project healthy and maintainable. Okay, let's talk about how API change over time. Specifically, we're looking at version deprecation and sunsetting policies. Think of deprecation as a warning sign. It tells developers that an API version is going away soon. You'll usually give them plenty of advance notice, around 6 to 12 months, with clear instructions on how they can switch to a newer, supported version. Sunset is the final step. Once the deprecation period ends, the old version is completely removed. It's important to maintain backward compatibility as much as possible so developers can smoothly migrate their code. And of course, good documentation and consistent communication are key to making this process as painless as possible for everyone involved. Okay, let's talk about how to really make your API shine. It's not just about building them, it's about continuously improving them based on what users are actually doing and needing. First, you need to actively collect feedback. This means looking at everything from simple user surveys to digging into your analytics to see where people are running into trouble, or what features they are using most often. Support tickets and even community forums can provide a wealth of information. Then, once you've gathered all this data, it's important to prioritize. Not every issue needs immediate attention. Think about how impactful each problem is and how frequently it occurs. Next, you actually build the fixes or improvements, and crucially, test them thoroughly before releasing. Finally, don't just release and forget. You need to monitor your API after making changes to see if those updates are having a positive impact, and then keep collecting feedback. This whole process is all about continuous improvement. Okay, let's talk about content type and accept headers. They sound a bit technical, but they are really important for how your API works with clients like browsers or apps. Basically, the server uses the content type header to tell the client what kind of data it's sending back, like this is JSON or here's some HTML. Meanwhile, the client uses the accept header to say, hey server, I can handle JSON and XML, whichever you prefer. Getting these headers right ensures everything communicates smoothly and avoids frustrating errors. It's all about clear communication between your API and its users. Okay, let's dive into API test automation frameworks. Think of these as blueprints for how you structure your tests. They help you keep things organized and efficient. We'll cover a few popular types: behavior-driven development, which uses plain language to describe what the API should do; keyword-driven testing, where you build reusable test steps; data-driven testing that allows you to run the same tests with different inputs; and model-based testing using models to define system behavior. The best framework for you will depend on your project specifics. Okay, let's talk about protecting our API. Rate limiting is key to preventing abuse and making sure your servers don't get overwhelmed. We have 3 main algorithms to consider. First up is the token bucket. Think of it like a bucket that slowly fills with tokens. Every time you make a request, you burn off a token. If the bucket's empty, your request gets blocked until more tokens appear. Next we have the leaky bucket. This one's all about smoothing things out. Requests flow in at a steady pace but are released at a constant rate, dropping any excess. Finally, there's the sliding window. This provides really precise control by limiting requests within a moving time window. These algorithms each have strengths depending on the type of traffic you expect. Okay, let's talk about keeping things secure and smooth when users are interacting with your API. First up, we've got JWT. They're like digital ID that prove a user is who they say they are without needing to constantly log in. Next, Session ID paired with refresh tokens give you more control over how long sessions last and ensure a seamless experience if someone's token expires. We also need to be smart about cookies. Setting the right flags can really help prevent security issues. And finally, it's important to have session timers, finding that sweet spot between keeping users logged in and protecting your application. Okay, let's talk about how we measure if an API is actually *good**. We don't just look at whether it works, we need to know how fast it works. First up is latency, as the time it takes for your API to respond to a request. Think of it like waiting in line, you want it quick. Then there's throughput, which is essentially how much work your API can do in a given time frame, measured in requests per second. And finally, we have error rate. This tells us how often things go wrong. Keeping an eye on all these metrics will help you spot performance issues and make sure your API delivers a fantastic experience for your users. Okay, let's talk about API governance. Think of it as the rulebook for your API. It's super important because it makes sure all your API work together smoothly and securely. We need things like an API style guide, essentially a shared coding standard to keep everything uniform. Then there's versioning, how we manage changes to our API so they don't break existing integrations. Detailed documentation is key. Something like Swagger or OpenAPI helps with that. And of course, strong access control and rate limiting are vital for protecting your API and preventing abuse. Do you have any questions about this? Okay, let's talk about keeping your API keys safe. Rotating them is like changing the locks on a door. It's essential for security. Why do we need to do this? Well, if someone gets hold of an old key, they can potentially access your application and data. Rotating keys limits the damage if one does get compromised. Think of it as having different keys for different periods. We have stages like creation, where you make a new key with specific permissions, active use when the key is working, expiration where it's automatically deactivated after a certain time, and revocation that's immediate disabling when something goes wrong. You can automate this process using tools or manually generate a new key and update your systems. And remember to regularly monitor keys for any unusual activity. Okay, let's dive into how we often connect with external API. First up is direct integration, basically just calling the API directly from your code. It's straightforward but can lead to tight dependencies on the external service. Next, we have the adapter pattern, which acts as a translator between your app and the third-party API, keeping things separate and easier to manage. Then there's the facade pattern. Think of it as a simplified front door to a bunch of complex API. And finally, if you need to interact with multiple API in sequence, the chain of responsibility pattern can really streamline things by creating a flexible workflow. Okay, let's dive into automating our API deployments. This slide highlights some key players in the CI/CD world: GitHub Actions, Jenkins, and GitLab CI/CD. GitHub Actions is really great for smaller projects because it's built right into GitHub and makes things super easy. Jenkins is a powerhouse, offering tons of customization options if you've got more complex pipelines to manage. And GitLab CI/CD? It's fantastic because it's all rolled up together within the GitLab platform itself, simplifying your entire DevOps workflow. Let's talk about how we can make our API services even more robust and scalable. The key is containerization. We'll be using Docker to package up our API along with all its necessary bits and pieces, creating a self-contained unit. This ensures that our API runs consistently wherever it goes, whether it's on your local machine, a testing server, or the cloud. Docker also dramatically improves resource efficiency, preventing conflicts between different applications. And then we'll dive into Kubernetes, which is like a conductor for these containers, automatically handling scaling, deployment, and all the other heavy lifting so you can focus on building awesome API. Okay, let's talk about making your API super reliable, specifically using cloud load balancing. Think of it like this: as more people start hitting your API, you don't want just one server getting overwhelmed and crashing. Cloud load balancers automatically spread the traffic across multiple servers, so if one goes down, others take over seamlessly. There are different types. Some understand exactly what's happening with your requests layer 7, while others focus on basic distribution at a lower level. Global load balancing is especially useful for reaching users all around the world. It directs them to the closest server for the fastest experience, and constantly checks that all your servers are healthy, rerouting traffic if needed. It's truly key to building an API that can handle any amount of demand. Okay, let's talk about SLA and contract enforcement, really important stuff for any API developer. An SLA is basically your promise to users. It outlines what level of performance they can expect from your API, like uptime or how quickly responses come back. But an SLA isn't enough on its own. Contract enforcement is all about making sure you actually deliver on those promises. It involves setting up monitoring tools to track if things are meeting those goals, having alerts go off when problems arise, and then having a plan in place to fix them quickly, like scaling your infrastructure if needed. Basically, it's a way to keep everyone happy and the API running smoothly. Let's talk about logging. It's a cornerstone of building secure and compliant API. Think of audit logging as your API memory. It records every action taken, who did it, and when. We want to track authentication attempts, the precise requests being made, and any errors that pop up. Beyond just spotting problems, this data is critical for meeting regulations like GDPR and PCI DSS, ensuring you're protecting user data and handling sensitive information securely. Okay, let's talk about the different types of API you might encounter as an API developer. Think of API like doorways. They allow different applications to talk to each other. We have three main categories: public, private, and partner API. Public API are completely open for anyone to use, like Google Maps or Twitter, with their limitations. They're great for building integrations or apps that need external data. Then there are private API, which are used with an asterisk, a company itself, like an e-commerce platform managing orders internally. And finally, partner API are shared with specific partners and vendors, offering a balance between openness and control. Think of a travel agency using an airline's booking API to offer flights. Okay, let's talk about making money with your API as monetization. There are a few popular ways to do this, like subscription plans where users pay for access based on what they use, or maybe charging per call if the API is used frequently. We also could offer a freemium model, providing basic functionality for free and then charging for premium features. Now, alongside monetization, you need a solid way to manage those API at scale. That's where API management platforms come in. These tools help you control access with authentication and authorization, monitor performance, handle different versions of your API, and even prevent abuse through rate limiting. Essentially, they're your central hub for keeping everything running smoothly. Let's talk about generating API documentation. One of the best ways to do this efficiently is by using annotations directly within your code. Think of them as built-in explanations. We'll cover why it's important, how it works, including picking a consistent style, and using tools like Sphinx or JSDoc, and even look at an example in Python using docstrings. Properly documented code makes everything much easier to work with down the line. Let's talk about getting your API out there. In today's world, we need to think about deploying our API in a way that's flexible and can grow with us. Cloud-native approaches like using containers and serverless functions offer fantastic scalability. But sometimes, you might have a mix of systems, a hybrid environment. That means some parts of your API might live in the cloud, while others stay on premises for reasons like compliance or performance. We'll look at how to connect these different worlds with tools like API connectors and even edge computing, bringing your API closer to the users who need them. Okay, let's talk about service meshes. Basically, they're like a hidden layer of infrastructure that takes care of all the tricky stuff when you have lots of different services talking to each other. A big benefit is how they handle routing directing requests to the right service automatically and making sure those services can even find each other without needing complicated configurations. They also provide features like circuit breakers, so if one service fails, others don't get affected too much. You've probably heard of Istio and Linker. Both are popular choices for building resilient and scalable microservice applications. Okay, let's talk about getting your API SDK off the ground and keeping them running smoothly. First, you need to build the core of the SDK, defining exactly what it does, designing simple and intuitive API for developers to use, and writing really good documentation so they can get started easily. Then think about which languages and platforms you want to support. Tailoring your SDK to where your users are most active is key. Next up, rigorous testing is vital. Write lots of tests to make sure everything works correctly, and regression test regularly as you add new features or fix bugs. Version control is essential for managing updates. Semantic versioning can be a great way to communicate changes clearly. Maintaining the SDK means fixing reported issues, prioritizing what needs attention most urgently, and most importantly, providing developers with a place to ask questions, give feedback, and even contribute improvements. Think forums, GitHub, or other community channels. Okay, let's talk about making your API accessible to the world. When you're building an API and want it used globally, you need to think about localization and internationalization. That basically means adapting your API so that it works well for people all over the world who speak different languages and use different formats for things like dates, numbers, and currencies. We'll cover key aspects such as providing translations, handling special characters correctly, and making sure everything looks right based on a user's location. It's important to set up a good internationalization framework from the start. There are libraries and tools that can really simplify this process. Okay, let's talk about speeding up your API. A huge part of that is caching. First up, we have Redis. It's a super fast in-memory database that can store frequently accessed data. Think of it as a quick hit for things like user sessions or even rate-limiting requests. Then there's CDN, which are basically networks of servers spread across the globe. They hold copies of your API content closer to your users, dramatically cutting down on travel time and making everything load faster. It's all about getting data to users as quickly as possible. Let's talk about keeping data consistent when you have multiple services all talking to it. It can be tricky in a distributed system. We often deal with different levels of consistency. Eventual consistency is like it will get there eventually. Great for when availability is super important, but things might not be perfectly synchronized right away. Strong consistency means everyone sees the same thing instantly, which is reliable but can slow things down. And then there's causal consistency. If one event causes another, you'll see them in that order across all services. The best choice really depends on what your app needs to do. Okay, let's talk about a key strategy for building robust API: dynamic rate limiting. Instead of applying a simple, fixed limit to everyone, we want to tailor those limits based on who's using our API. Think about it: a casual user shouldn't be throttled the same way as a power user or someone on a premium plan. We can look at things like how often they're using the API, their account level, and even where they're connecting from. There are different ways to implement this, from simple sliding windows that adjust over time to tiered systems with multiple limit levels, and even more advanced approaches using machine learning to predict optimal limits. Essentially, it's about giving the right users the right amount of access while protecting our system. Okay, let's talk about extending your API gateway. We can do this using custom plugins and extensions. Think of them as little helpers that add specific functionality beyond what the gateway offers out of the box. These aren't just for simple things. You can use them to validate data coming in, transform responses based on conditions, even implement custom security checks. Essentially, they let you tailor the gateway exactly to your application's needs. There are some common use cases like validating request formats, enriching responses with extra data, and handling authentication if needed. Here's a very simplified example showing how a plugin might be applied. It's all about plugging in logic at different points within the request or response flow. Okay, so let's talk about asynchronous workflows and how message queues fit in. Think of it like this. When a user sends a request to your API, instead of waiting around for the response to be generated, which could take a while, your API immediately tells the user, okay, I've got it. I'm putting it in the queue. Then, separate worker processes pick up those messages and handle them independently. This means your main API endpoint stays responsive, providing a much better user experience. Plus, if one of those worker processes fails, it doesn't bring down the entire system, just another message is put into the queue. Okay, let's talk about API fuzzing. It's a really powerful technique for making sure your API is secure and reliable. Essentially, we're throwing unexpected data at them to see how they react. It's like giving the API a good shake to find any weaknesses. We generate a bunch of random inputs, things that aren't normally sent or might even be invalid, and then send those requests to the API endpoint. Then, we carefully monitor what happens and look for signs of problems, like crashes or unexpected errors. It's a great way to uncover vulnerabilities you wouldn't find with standard testing. Just remember to start in controlled environments and be aware of any rate limits. Okay, let's talk about mock servers. These are seriously helpful for any API developer. Think of them as stand-ins for your actual backend. They provide responses to your requests without needing the full API running. This drastically speeds up development because you can test your front-end code even before the backend is ready. Mock servers also let you isolate and test different scenarios, saving on costs and making debugging a lot easier. We've got some popular tools like Macoun, which is super easy to use, Postman, which most of you probably already know, and WireMock for those who want more control. Let's talk about a really important part of securing your API, security headers. These are basically instructions you send back to the browser or application that tells it how to behave when accessing your resources. We're focusing on some key ones like HSTS, which forces HTTPS connection, super important for stopping attacks. There's also X-content type options, which prevents browsers from guessing what kind of data they're dealing with, and X-frame options that helps against click checking. Finally, content security policy is a powerful tool to control the resources your website can load. Implementing these headers consistently makes a huge difference in overall API security. Okay, let's talk about access control for your API. It's super important. Basically, it's all about making sure only the right people are doing the right things with your API. We need to know who is accessing our API and what they're allowed to do. This involves a few key steps. First, we authenticate them, verifying that they actually are who they say they are, often using something like an API key or OAuth 2.0. Then comes authorization, determining exactly what they can do within the API. And finally, rate limiting helps us prevent abuse by restricting how many requests a user can make in a given time. It's a layered approach to security that protects both your API and your users. Okay, let's talk about securing our API using JWT. Think of a JWT as an electronic signature on a piece of data. It guarantees its authenticity and that no one has messed with it in transit. We'll start by understanding what this signature actually is. It's created using a secret key like a password and some math, ensuring the token hasn't been altered. Then we'll walk through how to validate these tokens, essentially checking if they're legitimate, haven't expired, and contain valid information before granting access. Okay, let's talk about OAuth scopes. They're like permission slips for your API applications. Basically, when an app wants to access user data, it needs to ask for specific scopes. These scopes define exactly what the app is allowed to do. We have basic access, which lets apps read profile info, email, calendar, and photos, each offering a different level of control over the user's data. Now, always remember, only request the minimum necessary permissions to keep things secure. Okay, let's talk about something really important when working with webhooks: security. Webhooks are fantastic for getting updates from other services, but they can also be a point of vulnerability if not handled carefully. Think of it like this: someone could try to trick your application into accepting fake information. That's where signature verification comes in. It's essentially a way of confirming that the webhook request is actually coming from the legitimate source. The API provider generates a unique fingerprint or hash of the data and then adds their secret key to create a digital signature. Your application receives this signature, calculates its own fingerprint, and compares them. If they match, you know it's good. It all boils down to having a strong secret key that only you and the API provider share. Let's talk about managing your API sandboxes. Think of them as safe spaces for testing. They're completely separate from your live systems. First, you need to actually create the sandbox using tools like AWS or Azure. Then it's important to configure it correctly. Setting up the right network rules and security settings is key. You might also want to limit how much processing power and memory each sandbox uses to mimic real-world traffic without slowing down your main system. And crucially, if you're using any actual data in your tests, make sure it's masked or anonymized. Finally, don't forget to set up monitoring so you can keep an eye on everything happening inside the sandbox and quickly spot any problems. Okay, let's talk about something super important for any API developer: the terms of use and compliance policies. Think of these as the rules of the road when you are interacting with an external API. It's like a contract. They cover things like how many requests you can make, rate limits, what happens to the data you access, and essential security practices you need to follow. You also have to be aware of broader compliance regulations, such as GDPR or CCPA if you're dealing with personal information, and PCI DSS if you're handling credit card details. Always check the provider's documentation carefully. It's your responsibility to understand and adhere to these rules. Thank you for watching.